Hey everyone, this is Tony Bichet, your Physics 2C SI for Dr. Anderson. Today we'll be going over some things for the photoelectric effect and a couple things on Bragg's law. So the important thing that I want to touch on in regards to the photoelectric effect is something that usually confuses a lot of students, and I'll write it up here. So there are certain things that change the kinetic energy of the molecule. So before I even get into that, I think you guys remember from your chemistry classes what ionization energy is, and that's basically the amount of energy it takes for an electron to pop off. And you may think that it's pretty similar to the photoelectric effect, and it kind of is, but there's a huge difference. So ionization energy has to do with gaseous atoms, but the photoelectric effect um, has to do with atoms that are metals. So that is the biggest difference. So you guys will probably see this in your MCAT studies if you guys are pre-meds. This is a huge difference that you guys need to be aware of. So going along with this photoelectric effect, one other thing you're gonna have to be pretty accustomed to is knowing what changes the kinetic energy and what increases the amount of photons that are released. So the frequency, you guys have to find your own way of remembering these. But it's pretty easy to get them confused. But the frequency increases the kinetic energy, and then the intensity increases the amount of electrons, and this is the amount of electrons that are ejected from the metal. Um, so frequency has to do with the type of light. So you guys remember that frequency and wavelength have an indirect relationship. So the different wavelengths of light are different colors, right? So different colors of light are going to emit, if they have the same intensity, they're going to emit the same amount of electrons, but the kinetic energy of the electrons will be different. And the intensity of the light is really just the amount of light that is shown on the metal. So we can have one light bulb. Let me draw that better. We can have one light bulb here that is giving light, giving a certain intensity. We'll say that's I. And then if we add another light bulb, I don't think that looks like a light bulb, but bear with me, then we'll have 2I. So intensity, just the amount of light that's shown. The frequency has nothing to do with the amount of light, it's the wavelength of the light. So let's go on to these questions. So question one: when photons energy 5.8 electron volts hit a silver surface. I don't know why that's worded so weird. Determine the maximum kinetic energy of the photoelectrons in units of eV. So what are some important things that we have here? We have the energy of the photons, um, and we need to determine the maximum kinetic energy. So first, we need to find out what the work function for silver is, and that can easily be found online. And then we can use this equation, E minus the work function. So this silver surface will be the work function, and then this energy will be the Planck's constant times the frequency. And we can further subdivide the frequency as the speed of light in a vacuum over the specific wavelength. Um, okay, so number two is basically along these same lines. It gives us the wavelength, and we need to figure out the maximum possible kinetic energy of the emitted electrons. So we're going to use the same equation. It'll just be a little bit different in how we apply this. So I actually remember this one. The work function for sodium is 2.28 electron volts, and we know Planck's constant. We know the speed of light, so this can be h times c over L over lambda. We know the wavelength, and we know the speed of light. So it's plug and chug from there. So a lot of these questions that have to do with the photoelectric effect are really just understanding which variables go into which parts of the equation. Okay, so for number 3, this one is a multi-step question. So a photon of wavelength 4 times 10 to the negative 7 meters strikes a metal surface, and the work function is given here, 2.13 electron volts. So the first thing you have to do is calculate the energy of the photon. And this is pretty straightforward. Planck's constant times the frequency. Then we need to calculate the kinetic energy, and this is the equation we use for parts 1 and 2. And so we can just really just plug that in. And then part 3 is a little bit tricky. We need to find the velocity of the photoelectron. So if you guys remember from, I think it might be 2A, we learned the equation for the conservation of energy, and one of them, and just to briefly explain, total energy equals kinetic energy plus the potential energy. This gives us the total kinetic energy of the electron. So this equals 1/2 mv squared, and the kinetic energy we get from part 2 is what we're going to set this equal to. So and we need to convert this to joules. The kinetic energy given here, we need to convert it to joules, and we need to find the mass of something. And I want you guys to think of what mass we'll use, and the answer should be pretty straightforward from there. So number 4, we know photons are what give light to all objects it touches, but why exactly do they glow or create light? So I'm not sure if you guys have covered this yet. I think you're going to cover it on Wednesday, but think about energy diagrams and what exactly happens to electrons when they go up in energy level, and what happens when they go back down to the energy level. So what do they absorb as they go up, and do they emit, or do they absorb anything as they go back down to that same energy level? And that should be your line of reasoning for number 4. So number 5 and 6 have to do with Bragg's law. Let me write that here. And so this equation, the equation for Bragg's law is given by 2d cosine, sine theta equals m times the wavelength. And so these questions are pretty straightforward. I think number 5, number 5 is the only one you need to use this equation for. And so the answer that you're going to give is in terms of d. So keep that in mind. And finally, number 6, what should the value of x be given this picture of X-ray diffraction? So you guys are used to seeing the angle like this, but think about it in terms of how they give it here. And you guys will have to use a little bit of your geometric intuition when trying to solve this. But 2 things I want you to keep in mind. The angle of the incident light in relation to the surface, and the angle of the reflected light, or the reflected electron, in relation to the surface. And there should be to surface, and there should be a relation between 1 and 2 to help you figure out what the answer to this question is. And so I hope this helps when you guys go through the worksheet. If there are any questions, please feel free to email me. My office hours are Tuesday and Thursday from 2 to 3 p.m. And thank you guys so much for watching.